Chromatography literally means color writing and is a method long used for separating mixtures into their component items. You are probably familiar with paper chromatography, placing a spot of black ink on some paper, dipping it in water, and seeing the colors separate out. Chromatographic separation of mixtures requires that the components be able to exist in two phases, a stationary phase and a mobile phase. In this example, the stationary phase is the paper and the mobile phase is the water. Ion chromatography is the separation of mixtures of ions. There are many variations in the chemistry of the stationary phases in order to optimize separations of different target analytes. But here, let's discuss the mobile phase or eluent used for the separation of anions or negatively charged ions. In 1975, Hamish Small at the Dow Chemical Corporation introduced the world to his work on ion chromatography. The first eluent to be used for the separation of anions was sodium hydroxide. This eluent was ideal, since after separation the hydroxide ions in the eluent could be converted to water by a suppressor, allowing the signal from anions in the mixture to stand out. However, there were a few downsides to hydroxide as an eluent. On the usability side, preparation of hydroxide without contamination by carbon dioxide is extremely difficult. Early users found that, over time, carbon dioxide dissolved into the eluent, changing its ionic strength and causing poor reproducibility. Furthermore, handling of caustic chemicals can cause some issues. On the technical side, the high concentrations of hydroxide needed were too high for the early suppressors. Consequently, eluents using carbonate and bicarbonate mixtures were proposed. These chemicals were readily available and safe enough even for home use, washing soda and baking soda. The eluent could be suppressed to carbonic acid, which has a relatively low conductivity, and this eluent has a high ion exchange affinity, meaning relatively weak eluents could be used for the low-capacity suppressors of the time. Over time, suppressor technology improved, but the issues of reproducibility and preparation still prevented the widespread use of hydroxide eluents. Yen Liu and Nebojsa Avdolovic of Dionex Corporation wondered what ion chromatography would be like if it could combine the optimum sensitivity of hydroxide eluents, reproducibility even better than carbonate eluents, only water being handled by the operator. They patented the method of electrolytic eluent generation in 1998, gaining not only these benefits, but also instantaneous programmable eluent concentration gradients, bringing huge benefits to analysis times and performance. Requires only water to be passed through the pump, increasing system uptime. Consistent results, day to day, lab to lab, operator to operator. Carbonate eluents still have their place in modern laboratories as the established eluent for over 40 years. Hydroxide eluents, made using eluent generation, bring you simplicity and performance. Thermo Scientific ion chromatographs support carbonate eluents on all systems, and eluent generation of hydroxide eluents is available across routine and advanced systems. Choose what is best for you. Thermo Scientific Dionex ion chromatography, designed around world-leading chemistry, designed for you.